Okay, these will be the last 4 examples for this section. Actually, the last one's for the chapter, right? Because this is the last section of this chapter. Okay, so it says graph each function and then find the domain and the range as well. Okay, so let's graph the functions first using, this is a cube root, this is a cube root, this is a square root. So there's different beginning tables, right? Cube root, this is your table that you start with. You should have this memorized, okay? Cube root function is going to be -2, -1, 0, 1, 2 for the y values. And the x values are the cubes of those. -8, -1, 0, 1, 8. Those are the ones you begin with. This is the parent function. Cube root of x. But we need to change it accordingly. So here we go. Let's do this one. It's saying that I need to subtract 4 inside of the radical, but that means a translation to the right 4. So what I'm actually going to do is I'm going to add 4 to the x values to move it to the right. Okay, so all of these x values add 4. -8 plus 4, -4. -1 plus 4 is 3. 0 plus 4 is 4. 1 plus 4 is 5. And 8 plus 4 is 12. There's your x values. Y values, outside of the radical, the only thing that is happening is a 2. So multiply times 2. There's nothing being added or subtracted there at the end. So times 2. -2 times 2 is -4. -1 times 2 is -2. 0 times 2 is 0. 1 times 2 is 2. And 2 times 2 is 4. There it is. Okay? Graph it and you're done. Looks like I have negatives, mostly positives on both the x's and the y's. Okay, so let me stretch that out. I'm going to put it here in the middle so that it fits. This is going to be -4, -3, -2, -1, 0. So here's my y-axis. And I'll leave it open without the arrows because I'm probably going to have to go further. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's my x-axis. Okay? So, -4, -4. 1, 2, 3, 4. 1, 2, 3. Nope. 1, 2, 3, 4. -4, -4. Down here. 3, -2. 1, 2, 3, 1, 2. 4, 0. 4, 0. 5, 2. 5, 2. And 12, 4. So, goes this way. Hits that point, starts increasing, and then flattens out. There's your graph. Okay? So what happened to the parent function in this case? It got shifted to the right 4 units, and also it got stretched. Alright, let's look at 16. Cube root. So again, we're going to use this same table. Okay? Make your table that matches this according to what it tells you to do. Ooh, this one's interesting. There's an 8 in there with the x. I can't graph it yet. I cannot make my table yet. In all of these, it must be only x. Okay, x plus something or x minus something, but it cannot be 8x or 5x or anything x. Okay, so in this case, I need to simplify this first. Good thing is that they gave me a pretty easy number to simplify because 8 is a perfect cube. What is the cube root of 8? 2, right? So this is actually 2 times 2 times 2. So there's a group of 2's there that comes out. So when you simplify this, all you got to do is take out 2, and all you have left is cube root of x. That's your actual function. Okay? Why 2? Because 2 is a cube root of 8. 2 times 2 times 2 gives you 8. Okay, now we can make our table. Here we go. Inside of the radical, nothing's happening. Now that I took out the 8, there's nothing there. So my x values are going to be the same. -8, -1, 0, 1, 8. But outside of the radical, there's a couple of things happening. So what I'm going to do for outside is I'm going to multiply by -2, and then I'm going to add 5 for the y values. Multiply by -2, add 5. So multiply by -2. -2 times -2 is 4. 4 plus 5 is 9. -1 times -2 is 2. 2 plus 5 is 7. Right? Times -2 plus 5. Don't forget what we're doing. 0 times negative 2 is 0, plus 5 is 5. 1 times negative 2 is negative 2, plus 5 is 3. And 2 times negative 2 is negative 4, plus 5 is, what did I say? 2 times negative 2 is negative 4, plus 5 is 1. There's your y values. Okay? And now we can go ahead and graph it. Looks like my y values are up there. My x values are all over the place. So here's what I'm going to do. I'm going to graph it over here in this empty space. I'll erase it before I do that one. Okay? So right here. You don't have space for it. Negative 8. This is negative 8, negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0. Here's my y-axis. And then 1, 2, 3, 4, 5, 6, 7, 8. Okay, so negative 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right there at the top of my graph. Negative 1, 7. Negative 1, 1, 2, 3, 4, 5, 6, 7. Right here. 0, 5. 0, 1, 2, 3, 4, 5. Right there. 1, 3. 1, 1, 2, 3. Right there. And 8, 1. 8, 1. Right there. Here's my graph. There you go. There's your graph. So what happened to the parent function to become this? It got shifted up 5 units. It also got stretched by a factor of 2, and it got reflected as well. Okay? Alright, before I move on to number 17, we need to answer this question for both of these before I erase them. What is the domain and what is the range? Okay, the fast answer is, for all cube root functions, the domain is all real numbers, and the range is all real numbers. Why? Because you could plug in whatever you want for x. There are no restrictions here. Okay, so it's going to keep going forever in the x on the x-axis to the left and to the right. Also, it's going to keep increasing and decreasing forever. So the range is going to be all real numbers. Same thing for that one. Domain, all real numbers. Range, all real numbers. So just because it's a radical doesn't mean there's restrictions. It's a cube root. So the domain and the range are going to be all real numbers. Alright, now let's look at number 17. Okay, now let's look at this last one, number 17. Okay, be careful with this one, okay? This is not cube root like these two. That's square root. So you're not going to use this table. What is the table that we use for that one? The one we know and love. We love it very much, and we know it very well. 0, 1, 4, 9 for your x values. 0, 1, 2, 3 for your y values. Okay? Change it accordingly depending on what the table is telling you to do. So let's make our new table based on those transformations. -4 inside of the radical. That means to the right 4. So that doesn't mean you're going to subtract 4. You're going to add 4. Right? Let's do that. 0 plus 4 is 4. 1 plus 4 is 5. 4 plus 4 is 8. And 9 plus 4 is 13. Done. X values, y values. Outside of the radical, it looks like I'm multiplying by -3 and then subtracting 3. So do both. Multiply by -3, then subtract 3. So from these numbers, we're going to get new numbers here. 0 times -3, 0. Minus 3, -3. 1 times -3, -3. Minus 3, -6. 2 times -3, -6. Minus 3, -9. 3 times -3, -9. Minus 3 is -12. There's your table. That's what you need to graph. Okay? So I'm going to draw it over here. Looks like I have positive x values and negative y values. So I'm going to make my graph so that it has positive x values and negative y values. I need the fourth quadrant, basically. Okay? So let's see. 4, -3. 1, 2, 3, 4. 1, 2, 3. Right there. 5, -6. 5, 1, 2, 3, 4, 5, 6. There's -6. 8, negative 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, right there. And the last one, 13, negative 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 12 down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go, it does fit. And there's your graph. This is square root. You do not draw arrows on both sides. It keeps going forever in that direction, but it begins here. This is where it's born, and then it goes in that direction. Okay? So what happened to the parent function to become this? Remember, the parent function for square root goes like that, right? It starts at origin and it goes up like that. It got shifted to the right 4, down 3. It also got stretched by a factor of 3, and it also got reflected. Okay, so all of those things happened. Shifted to the right 4, reflected across the x-axis, stretched by a factor of 3, and then shifted down 3 is the last thing that happened to it. There is the result. What's the domain and the range of this? Be careful, it's not like these, right? It's not all real numbers, all real numbers. There are restrictions on the x values, there are restrictions on the y values. You can find it two ways. You could look at it here and say, what is the possibility of x? What is the lowest possible number that it could be? And you're going to say 4, right? 4 minus 4 is 0. If you plug in anything smaller than 4, like 3, you're going to get a negative inside. Doesn't work. Or you could look at the graph and say, where does it stop existing or start existing? It starts existing here at 4. Before that, it doesn't exist. So your domain is x is greater than or equal to 4. Range, same thing. Look at the graph. It starts existing here, and then it goes downwards. So in this case, y is less than or equal to negative 3. And if you look at the table, that makes sense. Y is always less than negative 3. It's never going to be bigger than negative 3. There's your domain. There's your range. There's your graph. All right, final one, number 18. Let's just do it real quick. It says write a cube root function in which the vertical translation of y equals cube root of x is twice the horizontal translation. This is really simple, guys. The vertical must be twice the horizontal. So here, pick a horizontal translation, whatever you want. Easy one will be +1 or -1, right? There. Horizontal translation is +1. Which means to the left one, the vertical translation must be twice as big. So the vertical translation, I'm going to make it down 2. That means to the left one, down 2. It's twice as much. Okay. If I put 2 here, I put 4 here. If I put 3 here, I put 6 here. And so on. Many different options for you. Okay, that's all.